Good morning, everybody. My name is Antonio Castro. I'm the CEO of the Masdima. And I'm here to present how we intend to change the way that airlines manage their daily operations, especially when faced with disruptions. And we hope to do that, I'm sure we will do that, without increasing the costs, actually savings, increasing the passenger satisfaction, and at the same time, the revenue of airlines. So, welcome to the future of airline operations. Okay, 8% of the annual revenue of the airlines is spent on irregular operation costs. That's $80 million per every $1 billion of revenue. That's a lot of money. So what about if we could save you $12 million out of that 80 million and increase by 1% your annual revenue? Would that be a good deal for you?
I would think so.
Yeah. Okay. So now let's see in perspective three of U.S. airlines. We have here Alaska Airlines with a gross annual revenue of $5.3 billion. Southwest with $18.6 billion, and American Airlines with $42.7 billion. These numbers are from 2014, okay? But for what we want to do, that's good enough. We intend to save $64 million in cost reductions for Alaska, $210 million for Southwest, and $510 million for American Airlines. And additionally, we hope to increase $53 million on the annual revenue for Alaska, $186 for Southwest, and $437 million for American Airlines. So that's a lot of money. How can we achieve this? There are, around our system, there are four main characteristics that, from our point of view, allow us to achieve those numbers. The first one is that we adopt passenger-centric management on the irregular operations. You might be amazed that most of the airlines, and they have been in the air transport industry for the last 26 years, starting actually as a flight attendant, okay? And most of the airlines, the commercial ones, and despite they are transporting passengers from one point to another, they manage their regular operations as if they were transporting aircrafts and crew members from one point to another. So this doesn't make sense, right? That's how they do it. There are reasons for that, okay, that are related with the complexity of the problem, and we intend to change that because nowadays the technology allows to do better. Okay. The second characteristic is what we call the simultaneous and integrated approach. Airlines tend to solve this problem in a sequential manner. Okay. You have three different points or different parts of the problem that you have to solve. You have to solve the aircraft part, okay, because you need an aircraft to do the flight. You have to solve the crew part because you need a crew to be there. And you have the passengers, right? Okay? So they typically solve this in a sequential way. Aircraft, crew, and then let's see what we are going to do with the passengers, okay? Our approach is simultaneous. We, with the technology, with the algorithms that we have, we allow to have these three different parts with the same level of importance, okay? And solving this problem together in several interactions. Okay, that's what we call simultaneous and integrated approach. The third one is personalized solutions. So, would you like to have a word to say when faced with a disruption? Okay, you have a flight delay, you missed your flight. So, would you like to say to the airlines something like, look, you are reaccommodating me in this flight, but I would prefer to go in another flight. Do you think that as a passengers, that would be something that you would like to have? provide some arguments or some feedback or even some arguments about what the airline is intending to do regarding the recommendations. We allow this to happen during this resolution process. Okay? As part of the system, there is an app that the airline can provide to the passengers, or the passengers can download, and besides being notified of the disruptions that are happening, they will have received a log or a set of choices that they can select one of them or can even refuse all of them and start to argue with the software agent, not the human on the other side, but with the software system. Okay? That's what we call personalized solution. And the fourth characteristic is real-time automation. We automate around 90% of the irregular operations process, from event detection to apply the solution. Apply the solution is to swap the aircraft, if that's the best solution for the aircraft part, to call a reserve crew member, if that's the best solution for that. And for the passengers, the solution is a new rebooking, a reaccommodation for the missed flight. We automate 90% of that part. We are not getting rid of the humans in the operation control center. The 10% part that is missing is the role for the human. Okay, the human has the last word here. Okay? With this real-time automation, we have a scalable system, because an airline can manage a larger operation without increasing the human resources. Okay? So, we, using the best of software engineering methodologies, plus the best of what artificial intelligence can provide us, we are able to put these main features in our system. Real-time operations monitoring. We monitor the operation in real time. We receive the information from the ACAS of the aircraft, so we can show even the position of the aircraft there, and also the impact of any event that has on the airborne flight. Event detection and what if. The system is permanently seeing if there is any event like an aircraft malfunction or even a crew that is missing, to report for the flight. And after detecting, always permanently detecting these kind of events to see if there is any problem. Besides that, we allow what we call the what-if scenarios. Human users on the operation control center, they can see, let's see, for example, from a maintenance point of view, we need to stop this aircraft, to do a specific maintenance. What will happen if we stop this aircraft for the next 2 hours? The system will show the scenario, including the impact on the subsequent flights of that aircraft, on each crew member roster, so schedule, and on each passenger of each flight, okay? Including the costs and the goodwill costs of that, because we don't only lead with the direct costs. We also have what we call the goodwill costs, okay? Then the impacts assessment. For every event, we see what happens in these 3 different parts. Integrated problem solving, that's where the artificial intelligence enters here. The system is able also to learn, and the software agents are able to negotiate between each other. That's how we solve this big problem. Human in the loop, as I told you, the human has always the final word regarding the acceptance of the solutions. Passenger interaction, that's what I told you in the beginning. Applying the solution to the operational plan, and also the forecast simulation. Airlines tend to prepare the operational plan well with a lot of answers for that. For example, typically 6 months, it's a period that they can use Masdima to run that operational plan. And using our probabilistic models, they can see the type of disruptions they are most likely to have and their costs. and they can make that plan more robust. Okay, so it's a way of, it's a kind of predictive analysis that we are able to do here. Now, how do we make money from this? We make money from license fees and from implementation projects. License fees, as we have currently our business plan, are calculated based on the number of aircrafts and the capacity, the number of seats of each aircraft. We are studying a way of getting a piece of those savings that we get to the airlines. Okay, but the problem sometimes is how we measure, the real savings that we are getting. So there are rationales for both point of views, so we need to work very, very well on that part, but we intend to do that. And of course, in implementation projects. This is not off-the-shelf software. We must need to have an implementation project for that. Now, in 5 years, from the point of view of the Masdima revenue, we hope to have around $20 million of revenue. And most of this revenue comes for Masdima from the license fees. Okay? The implementation projects, that's the yellow line on the bottom, is receivable for us. But we want to work with partners. So we will share part of the license fees to the partners, and most of the implementation projects will be for the partners. Okay? So in 5 years, a partner will be able to have around $7.5 million of revenue. Most of them will come in the beginning from implementation projects, but we are also sharing a part of the license fees to the partners. Okay, that's how we intend to get money. So what are we looking for? We are looking for investors because we want to increase our development and commercial teams. We are looking for partners for distribution and integration. And we are looking for a small to medium airline for proof of concepts. We are working in Europe we are ending one proof of concept with one airline in Portugal, the biggest airline, Portugal. And we are working with another 2 in Europe. And actually one here in the US region. But let's see how it goes. Because we would like to validate more what we have. And also helping in performing market research studies, that will be also good. Now, to end my presentation, I have a 2-minute video that I'm going to ask for you, that summarizes this. Some of the data on the video is a little bit out of date, but I think it will be a good help to understand what we do. And actually, this is an image of the software running with the TAP Portugal data. Okay, so it's not vaporware. We have the software running. Okay.
This is your airline. As with any other airline, your flights are vulnerable to disruptions. Weather, maintenance, and restrictions are your biggest challenges to keeping your operation on time. Studies have shown that disruptions can cause 66% of your flights to be delayed, up to 3% of the yearly revenue in increased costs, and an unquantified loss of passenger goodwill. Every year in Europe alone, disruptions affect over 4 million delayed flights, 315 million passengers, and 10,000 million euros in delay costs. Traditionally, airline operations centers try to fix disruptions in a sequential, manual, old-fashioned way. Disruptions are broken into parts, which are solved in turns. First the aircraft part, then the crew part, and only at the end, the passenger part. As you can imagine, this leads to an unbalanced solution. Introducing Masdima, a distributed artificial intelligence-powered solution designed to help your business minimize the impact of disruptions. At Masdima, we believe that distributed artificial intelligence is the key to optimize the way you handle disruptions. Distributed AI agents negotiate with each other during several rounds to compute the best possible integrated solution to a disruption. Masdima is also able to run simulations, so you can preview solutions and their costs even before disruptions happen. The last call is yours. Despite being an autonomous system, intelligent decision-making means that the human is always in the loop. To make sure you don't make the same mistake twice, Masdima learns from your operation, meaning that today's solution can be part of tomorrow's knowledge base. Our first batch of simulation tests with real operational data input from a major airline has shown that our solution can cut down your irregular operational costs by at least 13%. Masdima, overcoming disruptions in an intelligent way. Ready to take the intelligent step towards cost reduction? Visit Masdima.com for more information.
Okay, that's it.
This is your airline. As with any other airline, your flights are vulnerable to disruptions. Weather, maintenance, and restrictions are your...
Okay.
He knows plenty, but not computers.
Wayne and I were just, great video.
Yeah.
Did you pay for that?
We did the script ourselves, and we paid for the voice.
That was a good investment. It should lead off the presentation.
Yes.
I mean, it's like I ordered the hot dog and they brought me the bun, and for 15 minutes I held the bun waiting for the weenie to show up. That's great. I mean, that sums up
Should be in the
and everything
upfront.
afterwards.
Yes.
You're describing
Yes.
the recipe and how it's made, which is great. But boy, that should lead off. And
Good
we were
point.
laughing because one thing we've seen in the presentations, which we had to be told multiple times when we were in our MSTC program, was the pain. You want to concentrate on the pain and explain it, but in reality, your solution is the first thing you should lead off with.
Yeah, first it,
The explanation of the pain is, and that's true for all presentations,
Yeah.
I think. It's almost like it's almost like you're giving a PhD presentation, which is, here is all the pain and agony I went through to get to this point of getting the solution. Whereas as a customer, we want to hear, here's your solution. And
Yeah.
the problem we get, we're already, if we're an airline, we know the problem. We, and as airline passengers, we live the problem 66% of the time. So that's a great thing. I would start off with that, especially if you're pitching capital resources.
Yeah, actually start with the fact that you're taking the simultaneous approach. Every operations manager or an airline knows already that they do this sequential, and they hate it. Start with the fact that no more sequential. You go, okay, how do you do that? We have agents, one agent for the passengers, one agent for the aircraft, the crew. Anyone can relate right there and go, okay, so this is the work I'm supposed to do by hand all the time, and you're telling me that you can do it for me? Tell me more.
So how does this, all the airlines, the big airlines have legacy systems they usually manage. I don't get how this interacts. You can't do it independently. You can't get into the data you need to do any of this without interfacing with the savers and the workspace. So I don't see how this really does anything unless you can integrate it into it.
Yeah, but that's one of the good things about the multi-agent systems paradigm, is that it facilitates the integration of legacy systems. We can even agentify, that's the word that we use for that, those legacy systems. But it is true, this system needs the data from all the other systems that are in use at the airline. For example, in the case of TAP Portugal, that's where we are finishing the POC, we integrate data from the Compass system, that's a system from Fujitsu, that runs the aircraft schedule and the flight network and even the crew management. They are moving now to Jepsen, but we are able to interface with those systems as well. And for the passenger, as the PSS system, they use Amadeus, and we are interfacing with that. And even connecting to the loyalty programs, because one of the things that we use here is we capture the importance that the passengers give to the minutes of delays and also to the missing of connections. From the point of view of the passenger, not only from the point of view of the airline. Okay, so That's what we call the goodwill cost.
I suggest you guys become an IBM Watson partner, because Watson has hooks into Sabre, and which is the most widely used in the US. And instead of you trying to build hooks into Sabre, just query Watson for what you need. It's all online. You can become a partner, just go to, do a lookup for Bluemix, IBM Bluemix,
Okay.
and that's where you're gonna find the
Any special requirement that IBM requires that us to have? Should we?
Not really.
You need to be
Just-
Marlon's friend.
Just, well, no, you just need to sign up for the program, it will ask you questions, and then you'll find the documentation related to Watson for logistics, that is the area that they're using. And Sabre is one of the areas they are connecting.
But if you're in an operation of an airline, I worked in system control for Continental for a number of years. There is no plan. I mean, there's a plan that starts the day out, but everybody knows that 5 minutes into the day, the plan's out the window. It's all reactive to a system. It's a predictive type of system we're talking about. It's really difficult to predict it. And the risk of taking your system, because there's embedded crew management systems, and maintenance management systems, they're all inside this big legacy. And you're talking about layering something on top of that. It's now going to take the decision away from them and adding this layer of decision. It's a huge risk for airlines to adopt that. They won't do it unless you can put alongside of them and say, we'll work ours parallel to what you do, so there's no risk to you. And if we show efficacy, then maybe we'll think about it. And that's very difficult to manage that kind of data. Can your system manage that volume of data?
Yeah, you are right about that. We have to find a way of the airlines to trust on our system.
One blip on the screen is millions and millions of dollars. One big
That's true,
trade-off.
that's true. And to have a parallel plan is one way, and that's what we are going to do, or starting, or doing this time.
One suggestion, one thing we found when we were pitching Watson to a bunch of industries, don't say artificial intelligence. People get scared. Say assisted intelligence. We found that the word assisted intelligence, it's sitting next to the person, next to the human, your point, they're gonna add something.
It doesn't replace, it augments.
Exactly, it augments.
Yeah.
That actually gets you a lot of goodwill, and you know, the word artificial intelligence scares some people.
Yeah, they start to think about robots and human-like intelligence and that kind of thing.
They'll do it if you, I mean, they'll look at it, if you can test it, and deal with real-time data that they're dealing with.
Yeah,
And getting them to let you see into the data that you need to be able to test your system. It's difficult.
yeah, that's the first approach that we take with airlines. We typically ask them if they would like to do a POC with us. We have two types of, let's say, POCs. One, it's more like we build a prototype for them with offline data, okay, that they can run outside of their production environments, okay, and then they can have their own people or the OCC to use and to see how our system behaves. Okay. The other option is also part of the POC is to work connected live with their systems, but only receiving information without changing, the location of that. That's that kind of POC that we are doing with TAP.
But your
Live data.
value proposition is to change things in advance so you don't deal with the results of good decisions, because you're helping them to make better decisions.
Yeah.
So how can you do it just pulling data out? How can you test your system unless you interface with real-time?
Sure. That's what with TAP in this POC, we are interfacing with real-time data that they are using every day. What they don't do is update their operational plan according to the decisions of the people that is testing the system. That we don't do during the POC. Of course, when we sell to them the product, that's the way of working, because it also saves a lot of time. But one of the good things, and I think close to answer to one of your questions, is that, you know, that some of the solutions that you have nowadays are monolithic ones. So they are like tools to help, you know, the human operating on the OCC to solve a specific problem. The problem with those tools is that they expect that during, you know, the time window of the problem, nothing changes. Okay? And depending on the size of a problem, you might have a time window of 8 hours to 24 hours. And to expect that nothing changes during that time, it's no way. So it doesn't matter if you came up with the best mathematical solution, optimal mathematical solution, because at the end, it will be unfeasible. Okay? What we do here, and that was one of the biggest challenge, even in terms of computer power, is that in every round, as we call it, because the agents are negotiating between them, in every round we update the information live. Okay? That was a big challenge in terms of development of the system. But thanks to the cloud environments, we can have computer power on the fly. So.
One question, well, it's more like a apocalyptic prophecy. The problem I see is not related to address the problem, you address the need. There's a lot of interesting technical aspects to it, the whole issue. The problem I see is that this is a competitive advantage product. And with a competitive advantage product where you're going to give one airline a distinct competitive advantage, which is efficiency, on-time service, which they track constantly, and they compare themselves with each other all the time. All of those customer service, which is the number one problem with the airlines, customer service issues, and their irregular operations, percentages have been going up steadily since the computer age, really, since they took everything into that realm. The problem you have is that if I was running a small mid-sized airline, yeah, I'd absolutely license this, but I would never if I was a larger airlines, because I would want the exclusive license. I would want the competitive advantage for myself and myself alone, because the competitive factors in that industry are so overwrought. I mean, they're just everything, because they measure their profitability from one quarter to the next based on the smallest factors. And so the problem I would see is that it's almost like you need to find a large partner alone, that you, whether it's Sabre or somebody like that. I don't think that the problem with this product is I don't think you're going to be able to sell it to multiple airlines, because they're going to want, like I said, that exclusive license to secure competitive advantage. Whether they're small, competing with other small, or medium, competing with other medium, or...
But to the point they would turn down the competitive advantage?
Well, after the first one got it, yes, they would look for their own solution. I mean, Sabre creates its own software primarily. So they would back engineer. I mean, this is very hard to intellectually protect.
Yeah.
So
We have a pending, actually, but you are right. Even our lawyers needed to find, you know, specific parts of what we have and patent that part, trying to protect the.
And what I'm hearing is that you're teaching them to rethink the way they do things on a basic level. Well, if they see that enacted, they'll go make their own software that does the same base principle, which is, you know, deal with it not sequentially, but at the same time. So it's almost like the advantage of your product is going to be just we'll go write our own. So I don't know. You know, that we're doing this for 30 minutes and then drawing these absolute conclusions. I'm not saying that's true, but it's almost like I keep thinking you need to have a partnership with an airline. They have an exclusive license to this, whatever results, the final product. I just don't know if you can sell to multiple customers.
Yeah, you could do one of two things. You could be the Uber of the industry, I'm sorry, and work with the low-cost airlines. Look, every airline, the only differentiator they're going to have is, can I get you where you need to go on time? Because I'm not going to give you any food. That's not going to change. No airline's going to do it. So the only thing they're going to have going for them is, can I get you there without disruptions? You could work with the Ubers of the industry, Ryanair, some of the smaller ones, and then wait for a legacy carrier to come to you and say, okay, enough of that, I'm gonna buy you.
Yeah,
So,
exactly.
Right?
So, are you working with IATA?
Well, not working with them.
If you got the International Air Transport Association that covers all airlines all over the world to sponsor you doing this, that helps solve your competitors. And they do exactly what you're talking about here, is taking companies like yours, it's one of the small things they do, okay? And they make sure that everybody gets a chance at it. So if you don't have huge relationships with IATA right now, that's absolutely one of the
Unfortunately, this summer, I was invited by them to participate in Geneva in a conference they were having and to show this. But I couldn't
I will tell you-
because of previous
I will tell you,
meetings.
that
But
will be huge. The second thing I see out of this is your scenario planning, your role playing, and your simulation. I would see that if you wanted to create a strong competitive position for yourself in the marketplace, that create a certification program for the people that know how to use this. Say that I'm certified level 1, 2, 3, or 4, and I know how to do this. Okay?
it
And that
would be
would
also a way of making some money.
Good. Yeah, right.
Out of this certification program.
The third thing I would highly suggest is think outside the box. Don't think airplanes and passengers. Think international shipping containers and freight and trucks and steamship lines and rail cars and doing the exact same thing. There's a group called the Supply Chain Risk Leadership Council. SCRLC.com. Okay? Supply Chain Risk, SCRLC, Leadership Council.com. Okay? Get a hold of them. To do this for supply chain risk management, okay, scenario planning, okay, there's a tsunami in Japan, where's my shipments, how can I get my shipments rerouted, what's the best airline, what's the best trucking company, what's the best steamship line, how does it impact my customers, this has huge applicability in the supply chain risk area, okay? So you're now taking your airline thing, and you just exploded it into a whole new marketplace. Highly recommend you look at that.
Thanks. Yeah, actually, the research behind this was my PhD, and I didn't do research specifically for line operations. It was in disruption management.
Very
So
good.
all the category of problems that have a previous plan, that plan can be disrupted, and there is ways of recovering, they feel on this methodology. This was the prototype that I have done to prove, my hypothesis on the thesis.
Yep.
And it was actually went so good, and we won some prizes that we put as a product. But that's true. We could and we should go to
And
other
the marketplace then more than doubles.
Yeah.
More than doubles.
We need to remake our business plan and put higher numbers.
Well, thank you very much.
Good, thank you.